is my second attempt because the first attempt went bad. All right, so here, so we're talking about now, I mean, besides knowing if it's a positive or negative correlation or no, finding the equation line to predict. So it's not going to be perfect because, as you can tell, it's a scatter plot. So let's do the first one. What are the variables representing in the equation? Okay, so we're talking about the time you spend studying and your test score. As you can tell, they both increase, right? The more you study, the higher your test score. So that's what you can write here. What do the variables represent? X is the time spent studying, and Y is your test score. That's what the variables represent. What is a slope? Well, let's find it. So to find a slope, try to pick 2 points that you can actually know the value of, or approximate as best as you can. So I'm going to pick, and you shouldn't use, for example, this point and this point, for example, right? So you want to pick 2 points that are very close to the line. I'll pick this guy over here. And that looks like a 10 and I don't know, 68. So if it says if you study 10 minutes, you get a 68. So that's 1 point. Let me find another point that's easy to. Well, let me try that point right here. That looks like 30 minutes. 30. If you study 30 minutes, you get an 85. So there's my 2 points. 30, 85. All right. It's not going to be perfect, so as best as you can. So let's find the slope first. I'm going to do 85 minus 68. 85 minus 68, 17. And then 30 minus 10 is 20. And let me do that. I'm going to leave that as a decimal. Divided by 20, 0.85. So my equation, and then I already have the y-intercept, so I don't have to go ahead and do b. So I already have b, and it's 60. So my full equation is y equals 0.85 x plus 60. So that means that for every minute, right, y represents my test score. So remember, this represents my test score. Excuse me. And y represents the minutes. And 0.85 represents the number of points for every minute that I study. Okay, so that's right. Yeah. So the slope is the number of points that increase that you earn, the number of points that you get for every minute that you study. For every minute studied. That's what the slope stands for. The y-intercept, 60 here. So it's kind of weird because it says if you don't study at all 0 minutes, you get 60. So the y-intercept, b, says it's 60, which is saying that if you study 0 minutes, you get a 60. Well, how's that possible? Well, sometimes, not sometimes, there are classes, I guess, or schools where they can't give you a score lower than 60, no matter what you do or don't do. So let's say you bomb a test, or you do nothing, or you forget to do it, whatever it is, it's under a 60, right? And comes test score time, the minimum value you get is a 60. So no matter what, you're guaranteed a 60. I guess you can look at it that way. Looking at the equation, how do you know there is a positive linear relationship? Well, how do I know it's linear? Well, because first of all, the slope is positive, right? The slope is positive. And remember what we discussed in class the other day, when one value goes up, increases, one value increases, the other increases as well. So that's how you know you have a positive relationship. Okay. When it's negative, one increases, the other decreases, which I think we're going to see in the next problem. Yes, we are. All right, so this one says, starting 1970, when they started keeping track. So here, 0, right? This is actually 1970. 5 years after, this is actually 1980. And 10 years after, that's actually 1990, and so forth and so forth. Okay, so they started to keep track of this in 1970. I mean, that's true, but so in 1970, the percent of people who smoked was, if you can look at that, it's about 37.5%. So, and as time progressed from 1970, it seems like it's declining, right? So there is a negative correlation as time increases, right? As it goes from 1970, the percent of smokers went down. So what do the variables represent? The X is the number of years
which helps make them healthy, happy, and more adoptable.
After
Changing their life forever.
1970.
So they can change yours.
Y is the percent of smokers. What is the slope? Well, let's find the slope. Let's pick 2 points. Okay, fine. I can use this point, which is, that point is 40 and 15. Good. I need one more point. Well, I can use the one right next to it, which is, I don't want to use that point. Let me use this one, which is 25 on the x-axis, and that looks like 22.5 on the y-axis. Right, so 25 and then 22.5. So let's find the slope. Slope is going to be negative. So m, let's subtract. So 22.15 minus 15 is 7.5. 25 minus 40 is 15. Negative, right? So our slope is going to be 0.5. So my equation is y equals 0.5x. And let's find b. Although you can see b here, we can approximate b to be 37, I don't know, 35, 37, 37, but let's find b the old-fashioned way, right? So first of all, sorry, my slope should be negative, so let me rewrite this. So now I need to find the y-intercept, and let's negative 0.5x plus b. Let's pick a point. I'm going to use this guy over here. So y is 15, negative 0.5 times 40 plus b. 15 equals negative 20 plus b, so we're going to add plus 20 to both sides, and b equals 35, and look at that, we're not that bad off. Look, the slope, the y-intercept here is 37.5, but the slope that we found is 35. So again, and the reason for that is because, what do you call, the points here, right, are not all on the line, right? It's not a perfect linear relationship. So but that was just to confirm that the y-intercept that we got here through our point was 35, but the y-intercept that they gave us is 37.5. So we're actually gonna use the one that they gave us. So, but that's nice to know that we were pretty close. So our full equation is y equals negative 0.5x plus, and I'm going to use this y-intercept right here, 37.5. What is the y-intercept? What is the slope? Well, the slope says that the percent of people who smoke decreases by 0.5%. So the slope of negative 0.5 represents how much it decreases per year. Decreases per year. The y-intercept, 37.5, right here, the y-intercept, represents, the y-intercept b, the y37, it represents the percent of smokers in 1970. Okay? How do you know there's a looking at the equation, how do you know there's a positive linear relationship? That's wrong. It should be a negative correlation, yeah? Negative correlation, the slope is negative, and how do we know that? Well, one other thing that we can tell is as time increases, percent decreases, right? So remember, when there's a negative correlation, one goes up, the other one goes down. All right? Okay, This here, if you were to draw a line of best fit, it says here, well, we don't know what it represents, but it doesn't matter. So if you want to draw a line of best fit, first of all, I hope that you think you get something that's negative, right? As your x values, right? As your x values, x-axis here, increases, right? As it goes to the right, increases. Guess what happens to your y values? It decreases. So this is, first of all, a negative correlation. Why is that important to know? Well, if it's negative correlation, the slope is negative, right? And then if I look at my multiple choice answers, well, if you look at B, that's positive slope because it's 3 over 4. It says positive. D is 6. It's positive. So right off the bat, you can go and cross these two out. You don't even have to look at them, just based on what you see here. So that's gone, that's gone. Now, between the two of them here, they both have negative slopes. One is negative 3/4 and negative 6. But look at the y-intercept. One says that the y-intercept is 6, and the other one says that the y-intercept is 3/4. Well, now, if you look at my line of best fit, is, is it closer to 6, or is it closer to 3/4? Well, it's definitely closer to 6, right? That's my y-intercept right there. So just by looking and knowing what these numbers represent, we can answer the graphs, and we didn't have to do any calculations. All right, scatter plot below. A rate of which water flows through a garden hose. Okay, it's positive. So we know it's positive, and they give us the equation y equals 4/5 x. Okay, it goes through 0, 0. Makes sense, right? So 0 minutes, there's no water. So, and then it keeps increasing. If the rate in gallons per minute continues, approximately how many gallons of water will flow from the hose in 45 minutes? So is this in minutes? Yeah. So in 45 minutes. Remember, y represents the gallons, right? The amount of gallons. And x represents the minutes. And right now we have 4/5 of a gallon per minute. So if you have 45 minutes, all you got to do is replace, right? Because 45 is here, and if you were to continue this graph, right, if we were to continue this graph, the answer on the graph would be this guy right here. Right, we can predict it to be about there, but because we don't have the graph, we can use our equation. So times 45, right? So we're gonna multiply 45 to find our y value. So I know this point over here is 45 comma something, and that something, our y value, right? Our y value is what I'm trying to find. So y equals 4/5 times 45. Let's simplify that. And y equals 36. So in 45 minutes, you will have used 36 gallons. Okay, we should have made this bigger. The scatter plot shows the sizes, annual rents, okay, offices downtown in the city, okay? So, rent in dollars and the size of your office, okay? So, looks definitely like a positive relation, right? Correlation, and it seems like the bigger your office, the bigger your rent. Okay, annual rent. Okay, what would the line of best fit reveal about this data? Well, let's put a line of best fit over there. First of all, there's mine. Yeah, that looks like a good line of best fit, right? Says there's a strong negative relationship. No, that's garbage. There's a strong, so anything that's just negative, I'm gonna cross out. So A and D automatically, I'm not even gonna pay attention. There's a strong positive relationship. Sorry, let me move that line between the cost of rent and the size of the office space. True. There is a weak positive relationship. No, it's definitely not weak. If it was weak, the point would be like here, right? But notice that the points are very, 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 very close to the line. And the closer the line, the stronger they are. So our answer is B. Clear object. Okay. The eyesight of people of different ages. I can tell you that it goes. I'll tell you right now, it gets worse. She calculated a vision score for each person in the study and plotted the data. All right, so as your years, as you get older, what happens to the vision score? I can tell you right now for a fact that it's going to go down. Here's a line of best fit. Okay. So let's see. And she got an equation. So she picked 2 points. She wrote an equation. When the substituted value of 65 into this equation, what did the result tell us? Well, okay, so let's see. Her equation that she got is y equals negative 0.1x plus 1/10. So your score, so that tells you that your score decreases by 0.1 for every year that passes. Okay, so she's asking you, if somebody who's 65 years old, what would be her score? Well, we can look at the graph and sort of figure it out, but I guess they want you to substitute. So let's substitute. So y, our score, or the person's score, negative 0.1 times 65 plus 1/10. So let's see what that equals to. So negative 0.1 times 65, enter, plus 1/10 equals to 103.5. So I didn't need that. When she substituted the value of x equals 65 into the equation, what did the result tell her? Well, let's see. The result tells you that at age 65, your predicted vision score, not exact, right? It's going to be around 103.5 based on this study. It's a prediction. The exact value for the vision score of a 65-year-old, not the exact value, so that's not it. The predicted value for the vision score of 60, that looks good. The minimum possible value for a vision score of a 65-year-old and the maximum possible, no, and no. So the best answer to this would be the predicted. Predicted. We don't know if it's going to be the lowest score you can get. We don't know if that's the highest score you can get when you're 65. But we're saying that based on this study, it looks like when you hit 65, your score might be around 103.5. It's prediction. Okay. Oh, 2 more. Scatter plot. Which pairs could be points could be used to draw a line of best fit? Okay, so let's see what they tell us. Well, they're saying 4 and 7, 4 and 7, this point right here, and 8 and 4, 8 and 4. So they want to use these 2 points and draw a line of best fit. Could you use these 2 points? Absolutely not. Garbage. B, 3 and 3. So let's find 3 and 3 right here. 9 and 7, 9 and 7 right here. Let me draw a line of best fit here. Shoot. Well, actually, that's not bad, right? Using the 0.3397, that's not a bad line of best fit. So I'm going to keep this in mind. So this is possible. 2 and 4. Let me see. 2 and 4 would be 2 and 4. This point right here, and 6 and 4. 6 and 4. And this point right here. Would that be the line best fit? Absolutely not. So we know that guy is garbage. D, 3 and 2. 3 and 2, this point. Okay. 3 and 4. 3 and 4, this point. Okay, come on, give me a break. That's definitely not the line of best fit. So the line of best fit apparently was B, 3 and 3. And 9 and 7, which is right about here. And that would have been the 2 points you could have used to find the line of best fit. Okay, so right there. Last question. If I can read it. Oh my God. Scatter plot below shows the points scored and the points allowed by the Bulldogs football team for several games. Oh my God. Which association correlation best describes the data? So I don't know. When they score 2 points, they allow 14. When they score this many 8 points, they allow 21 points. Is this a positive? Ugh. So the higher, let me see. If the higher we score, let's say we score, the higher we score, the more we allow. Is that true? Let me draw a line best fit. Oh God. Definitely not a strong correlation. A, no association at all. It's non-linear. Non-linear would be something like this, right? Something like that, right? That could be something like that. So this one is like definitely not negative. It's definitely not positive. So the only choice here would be A, no association. Okay? Yeah, that's that.